Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, in this video we will discuss question number 9, 2016 NEET physics paper. So let us start with question number 9. Students, let us solve question number 9. From a disk of radius r and mass m, a circular hole of diameter r whose rim passes through the center is cut. What is the moment of inertia of the remaining part of the disk about an axis perpendicular about an perpendicular axis passing through the center? Here is a disk. It is the center. This has radius r. Now from here a circular hole is cut. Circular hole whose diameter is r. That means from here to here circular portion is cut like this, and it is touching the center and the rim. Now this much portion is now left. This much portion is a solid portion that is left. From a disk of mass m, that means initially the whole mass was m and radius was r. As this portion was removed, this is the for a complete disk, and for the small hole that is removed, the mass of that will be how much? First let us calculate that, then we'll go by the general method how to find the moment of inertia of this remaining part of the disk about this center and perpendicular to its plane. So from here let us find the mass of this smaller portion whose radius is obviously r by 2 because the diameter is r. Here the radius is r. What is the mass? Suppose the mass is m dash. Now because the disk is uniform, so mass per area will remain same. So mass per area of this one will be mass divided by pi r square, and for here this part of the hole the mass is this and area is pi of r square, that is r square divided by 4 because r by 2 square is r square by 4. So this will cancel, this 4 will come up and go down. This implies m prime is m divided by 4. This is the mass of this part of the smaller disk which is removed, it is m by 4, and the radius is given. So I can write the specification for this smaller hole which is m by 4 and radius is r by 2. Basically I can think of a negative mass system. I will consider that is this situation is equivalent to one whole disk is there whose mass is m and radius r. This situation is equivalent to this plus a negative mass m by 4, say, because that portion is m by 4, is this portion negative mass is put here at this place. If this is put here at this place, so this will become this one because this positive portion of this and the negative portion of this will cancel out and we'll have a disk with a hole here. So I have to find the moment of inertia. So the moment of inertia about this axis is same as moment of inertia about this axis plus the moment of inertia about this axis, because for this disk we have to find the moment of inertia about the tangent. Okay, so tangent and perpendicular to the plane of the smaller disk. So this is like that. So I have to add all these two, because and this negative has to be there. So that means from this full portion I have to subtract this one, and I'll get the result. So first of all, the moment of inertia, that is about the moment of inertia of the remaining disk, is actually the moment of inertia of the full portion of the full disk, about the axis passing through center, and the axis is fixed, that I'm not going to change, plus the moment of inertia of the negative mass disk. So I have to basically subtract it, or I'll take mass negative. So I'll take a smaller disk, smaller negative disk. So this way, for the full disk of mass m, radius r, the axis here, it is m r square divided by 2, plus the moment of inertia of the negative mass disk is this one is having mass minus negative mass minus m by 4, and radius is r by 2. About this axis it is half mr square, m by 4, r square by 4. This is negative. And but I have to find I have to shift the axis from here to here, because basically this is the same axis here. When the disk is cut here, I have to find about this axis, not about this axis. Shifting the axis to this, which is similar to this one, I have to use parallel axis theorem. So from parallel axis theorem, in fact, I will write the moment of inertia about this point, which is obviously this point O, about O, equals to the moment of inertia about this, which is minus half m by 4 r square by 4, and that is also negative. Then again I have to write everything negative, so it is minus, I'll write come out, plus of this value m r square, m is m by 4, r square m r square, this distance of separation between these two axes, which is r square divided by 4. This is a negative moment of inertia. Finally this has to be subtracted, or I should have found the moment of inertia about this axis, and that I could have subtracted it from this full disk moment of inertia. So solving this, I'll get, what is that value? Moment of inertia of the smaller disk, smaller one, is minus of, that means it has to be subtracted, that's by minus half of m r square by 16 plus m r square by 16. Okay, because that is 4 for the 16, 4 for the 16, so this should be there. Now it is m r square by 16, I take common, and this is half plus 1. Okay, so this is the 3 by 2, so it is minus 3 by 32 m r square. Okay, the 2 is 16 is 32, and the 3 is off, so it is that. Now I have to write this final expression, so I'm getting this is minus 3 over 32 mr square. Okay, and this I'm getting half mr square, so just I have to add these two numbers. So moment of inertia of the smaller disk is the remaining disk, I of remaining disk, is obviously equal to I of full plus I of removed disk. I of full disk is mr square over 2, and this comes out to be, just now we got this removed part is minus 3 over 22, so it's minus 3 over 32 mr square, which is given by mr square 1 by 2 minus 3 by 32, which is I can take basically 2 common out, so that it will be 1 minus 3 by 16 better. So this is 16 minus 3, that is 13 by 32. So it is 13 by 32 here, because it's 16 minus 3 is 13, 16 2s are 32 mr square. So 13 over 32 mr square, 13 over 32 mr square, so option number 3 is correct, 13 over 32 mr square. So therefore this is 13 over 32 mr square. So option number 3 is the right answer to this question. Okay, thank you.